Let's add or subtract rational expressions with different denominators. We know that if two fractions have the same denominators, we can easily combine them by combining the numerators and copying the denominator. What if they don't have the same denominator? Well, we need to make their denominators the same. Now, how do we do that? We know that if two expressions have exactly the same factors, then they are equivalent, and therefore they are the same. So we're going to use that idea here. We need to factor the denominators. So the first fraction here in this example, in the first example, 3 over x, denominator cannot be simplified anymore or factored anymore. So we just keep it 3 over x plus 6 over, 7x squared could be thought of 7 times x times x. So it has 3 factors. Our goal is to make these two denominators the same without changing their value. And so how do we do that? I need to multiply this x by 7x. If I do that, I have x times 7 times x, which is the same as 7 times x times x. Now the denominators are the same, but I need to maintain the value 3 over x. I don't want it to change, so I will multiply the numerator also by 7x, so that in effect, I just multiplied by 1. 7x over 7x is 1. So 3 over x times 1 is still 3 over x. Okay, so now I can rewrite this, and this becomes 21x over 7x squared plus 6 over 7x squared. Now they have the same denominator, and we can just combine them. So we'll have here 21x plus 6 over 7x squared. We can attempt to simplify this further by factoring the numerator and denominator to see if they have anything in common. The numerator we can factor out a 3, and this will be 7x plus 2 over 7x squared. And we notice that we cannot cancel anything because they don't have any common factors, so we stop right here. We can actually consider this as the final answer. But if you factored to attempt to simplify, we can stop here too. We can use this. So either one of these is a possible final answer. All right, let's move on to the next example. So same idea, we need to make the denominators the same. The first denominator is x minus 2. Second denominator, x squared plus 4x minus 12. X minus 2 cannot be factored anymore, but x squared plus 4x minus 12, we have to attempt to factor that. So since it's a quadratic trinomial, we're going to need a box. Okay, so this will be x squared, and this will be negative 12. So there are two missing numbers, and we know that the product of the two missing numbers is the same as negative 12x squared. You multiply this two, you multiply x squared and negative 12, that will be the same as the product of the missing numbers. And when we add the missing numbers, it's equal to the middle term 4x. So we'll have here 4x. All right, so now we think of what we multiply to get negative 12x squared and add up to 4x. And that's going to be 6x times negative 2x. 6x times negative 2x gives us negative 12x squared, and 6x plus negative 2x gives us 4x. So these are the missing numbers. So we put them in the box. We put the missing numbers in the box. Okay. Now, the box is complete. We have all the numbers that we that are needed in the box. We just need to determine now the length and the width. So we'll look at the first column and find what is common among the two terms there. And we notice that x is common to both. And so x times something is x squared, and that's going to be x. X times something equals negative 2x, so we'll put negative 2 in here. And x times something equals 6x, it's going to be plus 6 in here. So therefore, the factors are x minus 2 and x plus 6. So let's put the factors here. This is x plus 6 and x minus 2. So now we notice that they have the two denominators have a common factor, x minus 2. And to make them the same, we just need to multiply the first fraction by x plus 6 over x plus 6. So I'm going to put here, or I'll just put it here. I'll put here x plus 6 times x plus 6. Okay, so now that they have the same denominator, we can put them in a single fraction. So I'm going to put here x plus 6 times x minus 1 minus, don't forget to put in parentheses the second numerator, which is x squared plus 4x minus 4, all over x plus 6 parentheses x minus 2. All right, so now we just need to simplify. Now we have here two binomials multiplied together. We need to multiply the two. So I'm going to need to use a box. So x plus 6 times x minus 1. That's going to be x squared plus 6x minus x minus 6. So that's going to be x squared plus 5x minus 6. So this will be x squared plus 5x minus 6. We have to imagine a 1 here and distribute over these three terms. So we'll put here minus x squared minus 4x positive 4 all over x plus 6 times x minus 2. All right, now we simplify the top. We notice that x squared and negative x squared are opposites of each other, so they cancel out. 5x minus 4x is x. Negative 6 plus 4 is negative 2 over x plus 6 times x minus 2. Now we need to always simplify, so we can still cancel x minus 2. And therefore, the final answer is 1 over x plus 6. All right. Let's start working on the third one and see if you can continue working on it. I'll do a few steps and then you continue working on it. All right, so x plus 1 cannot be factored, x minus 2 cannot be factored, x squared minus x minus 2, this can be factored. And you can try making the box. I'm just going to put the factors here. It's going to be x minus 2 times x plus 1. All right, so if we make these three fractions have the same denominator, we notice that the first fraction is missing x minus 2. If I just multiply this by x minus 2 times x over x minus 2, then it will have the same denominator as a third fraction. And then the second fraction, if I multiply this by x plus 1 over x plus 1, it's going to be the same also as the third fraction. So then all these three fractions will have the same denominator. So again, I'll have